Oh. Hi, I'm Tom. I talk about code. Today, we're going to be back with some PlayStation 2 homebrew development. We're going to be fixing up and putting the finishing touches on the new and improved, fast C re-implementation of my 3D renderer. It's going to be awesome. It's going to be fantastic. I did a little bit of work off camera. I fixed some of the annoying small issues that were plaguing me. So I've got something to run and show right off the bat. First, I would like to thank Way Universe and Shoop2Hoop22 for following while I was offline, probably finding the stream through YouTube. So big shout outs to you if you're watching this later. And as always, thanks to all the awesome people tuning in from around the world, especially America and South America. So we're going to be moving in. Let's go. What's our folder called? PlayStation 2 3D test. Okay, so if I just run this off the bat, we're going to see that this is the fast 2D renderer up and running. Let me rebuild with some of this logging disabled, and we'll be able to see what's going on a little bit better. So if I go in, I cleaned up my makefile a little off camera as well, so I can now do a few cool things. If I just get rid of this log trace, clean everything, and then rebuild and rerun, we're going to get a much cleaner log. We're getting our FPS log, so we can see this runs at a clean 30 FPS. If I go into our stress test and I up the number of triangles, so this stress test works. It does 5 triangles across by 5 triangles down. So this is 25 triangles in total. We're gonna fly in here. We're gonna raise this number up. Okay, we're gonna crank this number up to 20. So 400 triangles, right? And okay, that doesn't look like quite enough triangles. Also, this is drawing at 8 FPS. And if I look, okay, this is actually using the slow Lua renderer, right? So basically, we're pushing a load of geometry, and it's slow, 8 FPS. If I swap this over to our new fast implementation and run, we're going to see this is going to run. This is going to crash. That's weird. Let's lower this number a little and see if it doesn't crash. Okay, let's go down to 9 by 9. Let's see what happens at 9 by 9. Okay, 9 by 9, we're fine at 30 FPS. If I swap this over to the slow renderer, let's see if we can see a difference here. We're going to see 30 FPS as well. Okay. Around 10 is kind of the critical mark where the slow renderer slows down. I want to see if there's a difference. The slow renderer here, of course, being a pure Lua implementation. Okay, so this is 30 FPS, right? We basically expect the fast renderer to always be 30 FPS. If we have a look, you're also 30 FPS. Basically, they're both fast. They're both pretty fast, which is good. So we've taken what was implemented previously in pure Lua, and we've wrapped it up in a global C object, and we can just drop in replace anywhere we were using the Lua version before. We can jump in and just use this hard-coded version. So let's make a plan for this stream. I mean, I think our top priority has to be working out a way to actually showcase that this new renderer is faster, or making sure that this new renderer is actually faster, right? I've seen it's faster, but if I can't show you, how do we know for sure? So let's get in here. Okay, so what are the goals for the stream? What are the goals? Let's add a new layer here. Sure. What are the goals for the stream? So first off, benchmark, right? Why is this benchmark broken? Why can't we show a speed difference? That's going to be kind of important, right? We need to actually know that what we're building is faster. This is pretty critical. At the moment, when I've been testing it out, everything's been okay so far. It's been falling over when we've been trying to split a draw over multiple buffers. So pretty much everything is working one for one the same, like literally drawing the same buffers. I've taken a few diffs of generated output. Sorry, I'm getting distracted by whatever is going on with my hair back here. I will get this fixed up at some point in the future. I am due a haircut, but today is not that day. But yeah, so at the moment, the buffers are pretty much one for one the same, but there's something slightly different when we're splitting draws over multiple buffers. I think I know what's going wrong. I just don't know how to fix it. So that'll be fun to dig into and investigate. We'll get to look at some buffers. And then if all that works, update dungeon game. right? We're going to pull these draw2D changes in. I said it was a drop-in replacement. That's actually not entirely true. If, for example, we look at our minimal example, right? We've got a new function here called screen dimensions. This is a bit of state that wasn't getting passed into Lua before. So for example, if we look at draw2d.lua, if we go into frame start, it calls this function buffer frame start, and it hard codes a width, a height, so basically now we just have a function that passes this in. I haven't actually updated our draw2d Lua to implement this yet, so I need to do that at some point as well. Let's go like 2.5 update Lua to new API. I was hoping to not make any API changes. Unfortunately, this one, just something that I kind of didn't really think out enough ahead of time. So small oversight on my part. So now with that said, let's just have a quick look at what I've done. I think this is all the diffs from last time. Like I said, we've added this new function. It looks like this is the only actual API change, right? There's one function, screen dimensions, which is good. We've added it to a few of our examples, but not every example. So we need to make sure that all of our existing examples work with this new code base. Very important, very, very important. Oh yeah, we've just played around with a few things. Whatever I was doing to count FPS here was kind of faulty, so I've just replaced it with the existing FPS counter that is actually, you know, part of the engine now. Apparently I hadn't updated this before. That was a bit silly. Played around with my makefile. This wasn't needed anymore. I've just made the makefile a little bit nicer, a little bit cleaner, and I've changed how the logging defines are thought of. I moved this print buffer function rather from DMA Lua, because now we actually use it in our C renderer as well, so we use it in more places. So we define this now in our log.h header, and we implement it, I think, in main for now. I don't really know where this kind of utility should go. Maybe we need like a utils.c file. That's something to think about. So now we can just have our print buffer functions there all the time. We don't have to worry about opening a code file and commenting out a line, commenting in a line, all that gross stuff. We can just have it there all the time. If we compile with our debug logs flag set, then it's going to get printed. Otherwise, it isn't. Really simple. Makes it a little bit nicer for us. So I think I started this gift tag new stuff last stream, right? I can't remember if I did or not. But basically, it's all the bit manipulation we were already doing in Lua. Now the logic is just ported to C. It's nice because where we were taking integer references before, we can now just use C pointers. That's really cool. That's really cool. Cleaned up a few like weird logical bugs. We're now tracking a draw buffer head and the size of a draw buffer. This just saves doing weird pointer subtraction when I kind of don't want to. This is all good. This is all good. I was building gift tags in the wrong order. I was putting the value in the higher byte rather than the lower byte. That was a fun bug, right? And this was a bug where I found it was actually really useful to just take a diff between two generated draw buffers. And this turns out to be something that's really cool and something I would like an easier way of doing in the future. At the moment, I have to run my code in PCSX2, copy out of the logs, copy into a file, you know, copy and rerun a different version of the program, copy that into a file, compare the two. What might be nice is if we could have some kind of program set up so we compile this rather than targeting a PlayStation 2, we target just like a normal processor, right? We run it on our machine, we run the program, and instead of actually, you know, trying to draw things and sending off DMA, rather than emulating a PlayStation 2 DMA system, we just pass off the draw buffer to some receiver program that's also running on our machine, maybe over like, you know, TCP, for example. And we pass it through and it can get validated or it can get compared, and we can make sure that we're actually generating the correct draw buffers. I think that's an interesting idea. That's been rattling around in my head all week, right? So we're gonna build that at some point, I think. But that's going to need a plan, right? That's going to be like a whole canvas like this, just thinking about what that means. But yeah, I've realized that I need to be more concrete about how I think about draw buffers. What else has changed? Just a bunch of like minor tweaks. I think some of this, yeah, this isn't the full diff from last stream, right? But the important thing is everything that was in Lua before pretty much is now in C and generates basically the same draw buffer. There's no major logical departures. We can just do things in a nicer way, right? Like, this is so much better. In Lua, we actually have to define this constant in C and then use it from Lua, because this kind of bit shifting, well, we don't have to. It just looks a lot nicer if we do it. This kind of bit shifting in Lua is pretty much a no-go. It's pretty much a no-go. Mimic Ring, hello, thank you very much for stopping by. How are you today? How are you going? God, and then, yeah, so we've got our coordinate conversion as well. This was giving me some grief. I can probably change this back to what we had. I might actually do that while I think of it. Okay, yeah, a few things we need to do. So let's jump in draw2d.c. And look, this is just a thing of beauty. Okay, this is a thing of beauty. Other than this, the first thing you see, ugly. This needs work. This needs some thought put into it. Always just allocating like a dumb array wherever PS2 SDK tells us we should alloc. Not a fan of this. We need to do better than this. But everything else in this file, pretty beautiful. Let's go to toCoord. Do we have... Yeah, we got a clipboard. Beautiful. You're good. You spent time working on PS2 stuff for your portfolio. Awesome. What is it that you're building for the PS2? I can't remember. I can't remember if you've told me in this stream before or not. I remember you saying about being interested in building things, but yeah, it's an exciting system. Cool. This function is really fun, right? Because the PS2 uses 16-bit fixed point coordinates, and I've talked about these so many times, right? If you've watched all of these videos, you're thinking, man, this guy loves to talk about 16-bit fixed point coordinates. But you bit shift 4 bits, because the 4 bits are the floating point bit, and then you take the floating point value of the number, right? Like the floating point component, which will be a number between 0 and 1, and you multiply it by the 4-bit number, right? The number that has 4 bits, and then you get this decimal point as 4 bits and the integer bit as the rest, and you cast this down to a wonderful unsigned 16-bit number, and then it just works. So if we build and run that, that's gonna... Oh, okay, well, it doesn't just work. Interesting. I regret talking about that so confidently. Okay, we've broken something. That's cool. You want to load a mesh and apply some lighting to it. Nice, simple place to start. It shouldn't be too involved. If you use like GSKit, it'll be pretty easy to draw the triangles. But yeah, object loaders aren't very fun. I think when I was doing this before... and trying to do everything in C, I think I actually wrote my .obj loader in C++, or I might have borrowed one, right? I might have borrowed one from... There's an online course. Hold on, let me see. There's a software rasterizer course that has a really good C++ obj loader. It's like super... I don't think it's this one. Super sharp, not very many lines. Maybe it's like a... I don't think it's this one either. Anyway, I found one online, and I may have borrowed it. Maybe it was this one. Oh yeah, no, I think it was. Triangle... I've definitely read this before. No, okay, this isn't the one I'm thinking of. Anyway. There are some really good examples out there. Borrowing stuff's fine. Yeah, I'm a firm believer in just like pulling in, within reason, as long as it's good open source stuff, right? Pulling in and following other people's examples. Okay, why did this explode? Why has this exploded? If we look at stress, right? So okay. We've done something really, really odd here. It's like 2 seconds into the stream, I've made one change and it's already exploding. So what do we say first? Benchmark. 0. We need a 0. We need an item 0. Fix coordinates. Which means I get to talk even more about 16-bit fixed point numbers. Let me just draw the picture again. I love drawing this picture, okay? If we have a 16-bit fixed point number, right? So 16 bits, yeah? We have 3 bytes integer part, 1 byte floating point part. We're taking a number which is just an int, okay? So we're taking some int x we want to split it out into two parts, right? We have, no, sorry, we don't have an int x. We have a float x. This is more complicated. Because the bit pattern of this number is very different to what an integer with the same like value would look like, right? So float x, we want int part, and we want the decimal part, right? The int part, we left shift by 4, right? So that moves it from like some number to some number that looks like, right? We want this 0 here, and we get this by shifting 4 bits to the left. We make sure that the lowest integer part starts in the 5th bit. And then the decimal part, we could actually just discard, right? We could just say this is 0, and then we like add these together into our final number, which we say is in like fixed point 16-bit format. I've been calling this FP16. If we want to be a little bit more adventurous, right? And I'm going to try and pick a color that doesn't look terrible with video compression. I realize that some of my drawings with yellow have been a little bit ugly. We could actually, instead of this, the decimal part, this is a number between 0 and 1, right? This is just what, if our number is like 5.1723, etc., we're just taking this part, right? That's what this is. So it has to be between 0 and 1. It can't be bigger than 1. So if we multiply this by 0xf or 15, right, we're going to get a number between 0 and 15. So we're going to get what will become the bottom 4 bits of this number, right? Did I say this was 3 bytes before? I meant like 3 half bytes. A byte and a half. Now, there are a few problems with this and the way we're doing this at the moment, right? This is the algorithm that I was using before. It was generating something odd. The first step is probably to just look at what's being generated here and compare it to what we're generating that we know works in Lua, right? Because if I jump over to the Lua implementation, I don't know why I always focus the wrong window when I jump between these things. Draw 2D Lua, right? If I jump over to the Lua implementation, triangle, where is this? Oh, two chord. God, it always focuses this window. It's so annoying. What we're doing is, so I is our integer part. We bit shift this by 4, which is the same as multiplying by 16. We add this offset, this magical offset that, well, we add this magical offset. Okay, I talked about this in length earlier, right? 0x8000 plus whatever we generate here. Or not even plus. I think technically speaking it should be or, but we're setting this high bit, right? Because we're treating 800, right? We're treating like the integer 800 as the middle of the range, as like the middle of the screen, basically. So everything is relative to this magical offset, and we could redefine our coordinate system to not do this, but this just seems to make more sense for a number of weird, complicated reasons that I've kind of forgotten. So let's go 08000 plus FFFO, and so we'll mask out the 16-bit part. We're going to add this number on, or maybe we should OR it. Maybe OR makes more sense, because we don't want anything to overflow, right? Set this bit, if it's... Now let's add. Forget overflow. It'll get truncated down, I hope. Now if I build and run, it looks fine because we're using the wrong renderer. If I go over to stress.lua, I need a way to toggle this without doing this much grunt work. This is a bit ridiculous, but there we go, perfect. It was the magic offset. So if we come down to 2 chords, we're missing this one critical part, right? So we're missing this bit where, So this looks ugly, okay? This looks pretty ugly. We're saying this number f minus the integer conversion of this number. So what this should do is like subtract the 5 from 5.1723, etc. Right? We're subtracting away the integer part and just leaving us with this decimal number between 0 and 1. This should be fine. This should be fine. Do we cast to an int? We cast to an int because just overcast, it'll be good. Int f. We wrap this in a lot of brackets. A lot of brackets going on here. Because you want a lot of brackets because this is a macro, and we have an expression like this, right? x1 minus 320. So when you expand this, you know, you don't want ambiguity. x1 minus 320. If you do this without the brackets, right? You imagine this is expand f without brackets, x1 minus 320. Is this x1 minus 320 left shift by 4, or is this x1 minus 320 left shift 4? I don't know, right? I haven't memorized the C-spec enough to know that off the top of my head. Don't leave it up to chance. Don't leave it up to fate. Just super superfluous parentheses. F undeclined. We've got a straight F. F has leaked. Okay, we're going to build again. 129. So somewhere we're using this. Somewhere we're using this. Oh, we've just pasted something by mistake. That's all fine. Cool. And now it looks like we've cracked it, right? If we just double check in stress, we're using our fast renderer, and we've now got a fractional part. So that's good. Okay, let's come in here, do something that I should be doing more of, cross things off of our list. We have fixed coordinates. Coordinates now work. We did it. We drew a cool flowchart. We did it. Benchmark. 20,000. Let's think. I might actually have to do these in a different order, right? So if we go into our stress test, right, we go up to like, let's go up to 20. If we run this, we crash. Because we're probably overrunning our buffer, okay? If we go to like 15, I don't know why I'm building. I just need to run. Okay, this is good. This is good. Now if I swap renderer, we get, yeah, look at that. There we go. We've got a benchmark. So this makes sense, right? What I'm doing has been fruitful. So this runs at 16 FPS. All I do is swap over to our API compatible, mostly, C renderer. I run this. We're hitting a smooth 30 FPS. This is only going to get more pronounced as I raise this number of triangles, right? I have not found a threshold where this number, where our FPS dips as we raise this number of triangles. The PS2 should be capable of drawing, I think it's 5 million untextured triangles per second, or 6 million, maybe 16 million. Hold on, I might be a tens place out here. Let me do like a sneaky. The numbers are out there. The numbers are out there. Where are you? 75 million flat, untextured, unaliased triangles per second. I don't know why I said that so emotively, but 75 million flat, foregone or off anti-aliasing. Texture off. If you texture that, the number of graphic synthesizer cycles doubles and it goes down to 37. 0.5 million. So 75 million triangles per second. So let's do some quick math. 75 times 10 to the 6. 10 to the 6. 75 million. 75 million divided... Hello? 75 million divided by 30. That gives us... and so then we want... 75 times 10 to the 6. Let's just like wrap this in an extra set of parentheses as well, divided by 30. So we should be able to get 1,000 by 1,000 triangles if our code is perfectly optimal before we hit limits on the graphic synthesizer. Of course, our Lua code isn't limited on that side. It's lured very heavily on the CPU side. So this is our theoretically perfect number, right? We're getting to 1/100th of this, and our Lua renderer has fallen over because it is so CPU bound. What we want is to be able to get as close to this number as possible before we see any kind of slowdown. Realistically, I expect we'll get to 100, and our code is basically going to shit the bed. But we'll see how close we can get to this. So this is our goal. This is our goal. Benchmark, we'll put a line through it, but we'll just make like a sub goal here. We'll say target 1.5k by 1.5k tries. You may notice as well when we run this that we have a little bit of like triangle drawing off the screen. That's not good, but I mean it's not that bad. We can live with it. It'll be fine. We should fix it, but what can you do? What can you do? I think actually I can fix it pretty easily. Let's just say 640, 0 to 448. Now if I run U, yeah, there we go. There we go. Except let's just like lower these numbers a bit. Let's go like 420 and 620. There we go. Look at this. Isn't this beautiful? Isn't this a thing of beauty? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 by 15 triangles. Beautiful, smooth, 30 FPS. Buttery smooth. Buttery smooth. Okay, so we've just added more stuff to an already messy commit. We're just going to commit all of this at once. Working 2D renderer that is fast. Perfect commit message. Was that the right passcode? It was. I can't believe I know that passcode, you know. Of all the numbers in my life, all the important, like, things I forget, I somehow remember this frickin' passcode. Awesome. Okay, I just got distracted by a bird out my window. So, multi-buffer crash. This currently works beautifully, but it's going to fall over very quickly when I make one simple change, okay? So if I come into draw2d.c, we allocate a buffer that is 20,000 bytes in size. That's great. That's a really good idea. Allocate a nice big buffer, fill it up with stuff, kick it off to draw. And we check when we draw certain things if we've overflowed this buffer size. If we have, all we do is call this draw2d kick function. What draw2d kick does, it actually submits the DMA chain, and then it sets up a new buffer. Now, the problem with this is, when we're just drawing 15 by 15 triangles, we don't actually hit this condition, right? So I'm going to lower this number so that it triggers. Let's lower it down to 2000. This is what I was playing with when the stream started, and this is why stuff broke when the stream started, right? So here we go. FPS is 0. We have no frames in however many seconds. We are not drawing any frames. Nothing is getting drawn. We stall right out the gate. So if I come into our makefile, d log trace, we're going to define this magic constant, make clean. We have to unfortunately clean and rebuild everything for this parameter to get passed in. This needs to be a configuration option at runtime at some point. We're not there yet. Cool. So we can see this is actually quite a big buffer, and a way to make this easier to debug is to come into stress.lua and just lower this number of triangles. Then we're going to have smaller buffers to do with. So well actually I guess if they kick, let's just lower this number to 5. I think that should be low enough that okay, it isn't. Right, I basically want less things in this buffer. I want less things in this buffer. Let's go to like 400. Let's go to like 800. That gives us 100 quad words. That's enough to start drawing some triangles, right? So we clear the screen, and then we've got some triangles. This is great. This is great. So let's copy this out. CD will work. PlayStation 2 3D test. Cool. So we've got buffer 1. Okay. Now we're going to run the same example, but we're going to go into stress.lua. We're going to swap our renderer, okay? We're going to swap back to this old, slow, crappy renderer. We're going to do the same test. We're going to grab this buffer. Yeah, let's grab this buffer. That sounds good. We're going to grab this buffer. We're going to drop it into a buffer called B2. And then we can compare the two. That sounds good. That sounds good. Cool, so we've got buffer 1. Let's look at buffer 1 first, right? The first thing this says is we've got a DMA CNT tag with 0x54. So if I go 0x54, that is, if I go 0x54, that gives us 84 elements, right? 84 quad words. No, 84 quad words. So 84 times 8, that gives us 600. Does that check out? If I go back to draw2d.c, what was my magic constant? 800. So yeah, okay. You can see where we're like triggering this. We're hitting this at a certain point, right? We're getting close to this threshold, I guess. Quite close. I don't know why it's triggering less than 800. Anyway, let's just follow this line through and see where we end up. Okay, so gift tag, we're setting a register with AD, we're setting up things to clear the screen, clearing the screen, unsetting registers from clearing the screen. Then we set the primitive register, we set it to, no, this isn't the primitive, is this the primitive register? 3, we set 0 to 3? Yeah, we set the primitive register to the value of 3, which is the magic number for triangles. We draw triangles. Originally, when I did this, by the way, these were the 2 bytes that were swapped, or the 2 double words that were swapped that were causing me issues. So I was drawing sprites instead of triangles, and that was a kerfuffle, let me tell you. Okay, so gift tag, 4 registers. That's color, position, position, position. We're doing this C times, and C is 10, 11, 12 times. So 1, 2, 3, 4, 5, 6, 7. No, hold on. 12 loops of 4. So anyway, you can really easily see where these are, right? These groups, you get this really distinct color pattern. You always get this 80 in the lower byte. So basically we count this 4 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I said we count that 4 times. I think I meant we count it 12 times. So 12, that ends, and then we come up here. And we have a DMA end tag. Now I suspect this number... No, this number looks good, right? We have from start to finish. This is 84 lines, right? Here to here. That's 85 lines. We're one off. We're off by 1. It could be that simple. But that gift tag ends properly, which is good. I don't think we need anything special there. Okay. So if I look at draw2d.lua kick. When we kick, DMA send chain, new buffer. DMA end continuation, end tag, send chain. And then we just start a new buffer. If I, God, that's annoying. Draw2d.c, draw2d, 2d kick. Look at this. End continuation, end DMA, end continuation, end DMA. Send chain and then initialize a new buffer. The only thing I do differently is start this continuation, but that should be fine. I guess another thing to consider actually is the possibility that because we don't wait for this DMA transfer to complete, we actually start overriding it in a way that tanks the transfer. So let's put a DMA wait in here. I think we just go DMA wait fast, and that should build and run. Did that actually build and run? Yeah, that's fine. So stress.lua, we're going to go back to our fast renderer. We're going to run, and it dies. Here we actually send a few buffers before we die though, which is interesting. So we send a buffer, and we're all good. Then we send another buffer. Oh, and we're not all good. We are very much not all good here. This, something's gone really wrong. Can you see the difference between these 2 buffers? So this first buffer we send, this looks great. This is what we just looked at. This is fine. But this is a disaster. This is not what we expect to see here at all. This looks like... So this is... This is a gift tag to set... This should be a 1, not a 32. This is the DMA tag value. Mighty Sledgehammer 8030. As an upcoming software engineer, I think what I find in this process cool and fascinating. Looking forward to more videos, but for now, good night. Thank you very much. That's awesome to hear. I'm glad that, I can be inspiring some upcoming software engineers. I definitely know that I've enjoyed watching videos like this over the years, and yeah, it's awesome to think that people are enjoying watching them. Thank you very much for the message, and have a good night. So what's happening here, okay? This is a weird Frankenstein hybrid of a DMA tag and a gift tag. This shouldn't be happening. This is our problem. And this is, I kind of hinted at this, right? I kind of hinted that I suspected something like this was going on. I didn't realize it was quite this bad. So, when we... Oh, I'm in the wrong frickin' window. Okay, so... Something here. Maybe start CNT is not actually updating our head. Oh, I see it. I see it. Do you guys see it? I see the problem. I found it. So after we've done our DMA submit, we'll wait here. This is a bit crappy, but we'll do it for now. Actually, no, we won't do it for now. Screw this. We make a new buffer, right? So what does new buffer do? New buffer resets our head to the start of the draw buffer, and then it just resets our state. We can actually probably get away with not setting this, only unsetting this at frame start. Anyway, we'll be a little bit inefficient for now, right? So we go back to here, yeah. And then we start a CNT. So start CNT. Start CNT, right, it does the normal stuff. It flags that we're in a continuation. It sets the head. It puts the actual frame buffer in memory, and then it advances our draw buffer head and our draw buffer size, and then we reset our draw buffer head. Why do we do this? We already do this here. Why do we do this again? What am I doing? I'm trying to be too smart. Get this out of here. Now when I run, it's just going to work. Perfect. Perfect. Okay, so now we can, first off, let's get rid of this. Let's get rid of this spam. Let's get rid of this log spam. We don't need this. We've fixed all our problems. We're not going to have any more problems. Okay, so now when I run, I need to clean first. Cool. We run. Look at this. Nice clean logging. Okay. Stress.lua. Let's set this to a much higher value. I've never run this with anything over like 20 triangles before. Let's try 100 triangles and see how our FPS goes. Okay, our FPS is hurting. But if I try and run this with the Lua version, I don't think it'll get any frames at all. I expect it'll just like crash or something. Something bad will happen. Oh no, there we go. We get like one. So my FPS counter mins out at 1, right? It cannot track fewer than 1 frame per second. So this is slightly less than 1 FPS, I think. This is probably like 0.8 frames per second, maybe. We can see the stats at the top, right? So the EE is going at 50% efficiency, right? Like half of its time is being spent filling this up. The GS, the graphic synthesizer, hardly being utilized at all. Let's compare those numbers to what happens in the fast version, right? The fast version should still be chewing through a bit of CPU. Actually, surprisingly similar numbers. But anyway. So our renderer is enough to draw 100 by 100 untextured but colored triangles with flat shading. We should be able to draw many, many more triangles than this, right? Interesting. So this is, we're struggling to draw 100 squared triangles per frame, which is 30 times, so 30 times 100 times 100. So is that 3 million? That's 300,000. We should be able to draw way more than 300,000 triangles a second. So we've got to assume at this point that there is another Lua bottleneck in here. Our actual drawing code appears to be much more efficient, but I'm guessing this structure is slowing us down. But we've got 300,000, and you know, I guess that does kind of make sense. Maybe if we put like more geometry in here rather than like you know, in the innermost cool we like do more stuff and then make fewer cools through the loops and do less table insert and, you know, like less stuff to loop over basically. I don't know. This number is too low. This number's too low. But we'll roll with it for now. So important that we've got a benchmark. Important that we know we're way off this target. We fixed our multi-buffer crash. Let's... Yeah, we'll keep stress in its current state. What does our diff look like? Oh, this isn't good. Okay, well, we'll deal with that. All I did was remove one line. Oh, and hold on. Whoa. No wonder we're getting such a low number. We're submitting like we're submitting way more often than we need to. We're triggering way more noise than we need to. So first off, stress.lua. Let's find that stray letter O. Stray letter O, where are you? There. Draw2d.c. Let's find where we put this stray 800. Hold on, there it was. We change this back to 19,000, I guess. And if we run, we still go at 5 FPS. That's a bit disappointing. 5 or 6 FPS, somewhere in between. I would have thought this would go a bit faster. And maybe there's a bit of tweaking we can do. Maybe making that buffer smaller will give us better performance. Maybe like 10,000 is a better number. Like 10 kilobytes at a time. I don't know if there's an optimal. But either way, that is something. It'll be interesting to see actually if we, for example, start drawing texture triangles, if our performance changes or not. Because if we can draw this many texture triangles without the number changing, that'll be a fairly good indicator that our bottleneck is the CPU and not the GPU. Because the GPU should be able to draw, well, I mean, I guess, so like a bells and whistles triangle, right? So a triangle with texture, with garage shading, with fogging, and with anti-aliasing, okay? That should give us 16 million triangles per second. So if we think about 16 times 10 to the 6 divided by 30 FPS, that should give us, even that should give us 500,000 triangles. So we're in the ballpark for the bells and whistles triangle. But we should be able to draw just like crappy triangles way, way more efficiently. Like, I guess it's the same. It's an order of magnitude, right? Yeah, we are one order of magnitude short. Okay, that's not great, but we'll wear it for now. Fix multi-buffer draw for... we don't need to say for 2D renderer. Our whole branch is called 2D renderer. Okay. And we're going to git push. So let's see if we can pull this into our dungeon crawler. Collision. Oh wow, I really did start this, hey. I can't remember if I did... I don't think I did this on stream, right? I think I was just playing around with this off stream. Oof. Wow. Okay, well let's check out a branch, just to check out this new 2D renderer. So if we come into our makefile, we have a git commit hash that we get our engine version from. So if I just jump over, I grab the commit hash, we'll grab down the new version of the engine. Oh, someone else has starred the repository on GitHub, by the way. 8 stars. I'm basically famous, guys. Yeah, where are we? Branch. We're going to go into C, draw 2D. Something fails. The linter fails. That's unfortunate. We're going to grab this commit hash. Okay, so I want to call... Oh, hold on. Do I... What's this? Main.lua. This needs to exist somewhere else, hey. Do I main dot... I've got to work out what this file actually is. Engine main.lua. GIF. Diff. Yeah. So we need a main.lua in our engine, but that has to come from the host program here, which is like the dungeon crawler. So maybe cp engine main.lua into the assets. There's some other stuff here, right? So script main.lua. Oh, this is fine. Yeah. These are just things that get copied in. Okay. I'm going to assume that this is all good and nothing's going to break if I run the makefile rule to pull in the new engine. So make get engine. And it's gonna grab it, it's gonna clone it. Perfect. Okay. Let's see what went wrong there. Base path too long. Yeah. That was one of the changes I made to the engine. So if I go into the engine real quick, source main dot c base path. Basically, that my search directory was too long, too short rather. Yeah, sure. Load all dist. For some reason still including fennel here. Where does that come from? I mean, fennel can just go. There's no fennel left, right? Oh no, there is. There is in this version. Maybe? Maybe not. Let's just assume that fennel's gone. I think we're good. No fennel. No, there is still fennel. Okay, hold on. Whoa. I want to check out the branch that I was on before. I'm gonna go into collision. I'm gonna grab this new engine hash, right? So basically, I need to work with a newer version of my code base that had fennel cut out. I forgot that I hadn't cut fennel out of the main branch yet. I just need to make a pull request and merge it. I don't know why I haven't done it. Oh wait, I didn't need to do that. Because the engine folder isn't checked in, it just ignores it. I could have just left what was there. Engine make docker elf. I probably need to change the file path thing again. Yeah, base path too long. Okay. But I know what I'm doing this time. cd, hello? Engine vi source main dot c base path 150 make docker elf there we go. Now we're thinking with portals. Okay, so our draw 2D has fallen over. Something is not working. Something's trying to do arithmetic with a base pointer. Placed into dungeon, script draw 2D. Is it because we've changed textures? We changed textures, didn't we? We changed how textures worked. Frame event. God, we don't get good backtraces, do we? What was resource, right? Load texture, yeah, okay. So this has to happen not here. I need just like a dummy frame up front where I load resources. Oh, this is more work than I thought. This is more work than I thought. I shouldn't do this in my collision branch. Okay, here's what I do. Check out B. Look at that, it's a new branch that doesn't have a name similar to other branches at all. So we're going to work in a new branch, we're going to incorporate this, but we're going to merge the collision stuff first, I guess. And then it's fine, it'll be like no one ever knows, right? No one will know. So, now we're going to get our hands dirty, right? These texture changes. What happened in these texture changes? I'm going to pull up the git diff from when I merged this. Have I merged this? I'm going to pull up the branch where I haven't even merged this yet. Texture issue? No, that's not it. Better DMA source change. Yeah, this is it. Okay, so here's the diff, right? So, oh, I've added this nice documentation as well. Isn't that lovely? UCNT, NCNT, yeah. So this stuff all just happens quietly behind the scenes. DMA start, DMA end, DMA, draw kick. Load texture now works very differently. It expects very different things. Yeah, so load texture just gives us the TGA. Alloc texture just makes it resident in memory. And then we have to call upload texture during a frame in order to actually get it into memory. So, script resource.lua. So let's split this out. So that function res upload textures. Right. And we'll actually call this the first frame of the menu. The first frame of the menu will upload these textures into VRAM. That makes a lot of sense. So we say draw 2D. Interestingly here though, this draw 2D, we have to use the Lua draw 2D for this. We have to. So this frame, but then we can't mix and match. It's a bit of a pickle, isn't it? That's a lot of a pickle. I'm getting ahead of myself here, right? I actually cannot do this yet. I cannot deal with textures yet. The only thing we could really do about this is to just draw untextured rectangles. But no, we can't mix and match Lua and C. This is one of the only drawbacks of this approach, right? We can't. They're using different memory. I guess I could make them use the same memory, but sharing the state would be just too ugly. If we were to do that, we would have to put all of the work on the Lua side, because I don't want the C side to be concerned with any of that. I think we're better off just maintaining two completely independent renderers, right? The goal of having two renderers is that the Lua renderer is easier to implement and easier to quickly fiddle around with and experiment with. The C renderer is slower, it's slower to change, right? It's more static, it's more verbose, but it's a hell of a lot faster. That's the goal. That's the dream. Okay. So in conclusion, that was a bit of a fool's errand. Let's go back to 3D test. And let's do something that was not in the original plan, right? Which is implement the rest of the API. So we go into texture.lua and we change this over to local d2d equals fast draw2d. Is that what I called it? I don't think I actually showed this, by the way. Draw Lua.c, we create just a global object called fastDraw2D. We bind C functions to names. So for example, our triangle drawing function gets exposed to Lua. Nothing too fancy here, but yeah, we're short a few things, right? So if I run this as is, if I go into our main script and change what actually gets run this as is, it's going to crash because we don't have methods implemented. So let's have a look at Draw2D. Well, let's have a look at our texture example even. That's going to be a better place to find it. So what don't we have implemented here? Draw2D load texture, we don't have. So let's go into Draw Lua. Load texture. Actually, do you know what might actually... Load texture doesn't use our draw buffer. We can actually use the Lua implementation of this, right? VRAM alloc texture doesn't use our draw buffer. We can actually use the Lua implementation of this. So what might be more cute than adding it into this blob would be in PS2 init. Maybe in PS2 init? What if we grab this library and then we say fast draw, we set the fields in this, right? So we say fast draw2d, what are the functions called? Load texture equals d2d.load texture. What if fast draw2d.vram alloc texture equals VRAM alloc texture equals d2d.vram alloc texture. Right, and these ones, they're just fields, right? So if we look at them, right, dot. They don't take the self parameter, so we don't have to worry about the state, so we can just have them transparently pass through here. And we want to wrap this in a function, maybe. Oh, you know what? Let's actually put it in here. This is part of our startup. I want to avoid requiring things in this file, but this is actually part of our startup. So if I run you now, we get some TLB misses. That's cool. What actually happens here? Hold on. So, pico time, total runtime. Oh, we actually get through to this cool, right? We get some TLB misses. We try and load some stuff that is not good. Test TGA. We're loading a file that doesn't exist. Or we're reading from a file that doesn't exist. TGA.c. We really need to check if f is nil. What return value am I using here? Return 1, yeah, so let's just do that for now. Function log error. Yes, I do mean log error. Thank you, C compiler warnings. Please don't do that. Nice. So we actually pick up when files don't exist now. Isn't that good? Isn't that lovely? But then we hit this upload texture function. This is going to be fun to implement. So draw2d.lua upload texture. It's actually not too bad. It's actually not too bad. It's going to be a little bit cleaner. Setting these registers, oh man, it's going to be a mess. So short of setting these registers, right, all we have to do is a couple of loops, build some DMA refs. I think I'm going to have to leave it for next time, unfortunately. This was productive, right? We got some stuff happening. We realized what our abstraction couldn't do. I'm actually pretty proud of this. It's not particularly clean, but recognizing what we can actually keep from Lua, right? Just minimizing the overhead of maintaining 2 compatible drawing APIs and using Lua for what Lua is actually really good for, right? Expressing the logic of VRAM allocation. Lua is really, really good at that, right? Expressing at a high level how we should load a file, right? What bits of information we actually need. Really, really good at that. And what structure we need that information in, right? We don't need this to be particularly inefficient. We're not going to be loading textures 300,000 times in a frame. We can just keep this. So next time, let's make a note. Not yet. This was overambitious. Next time. We're gonna have a few important goals. Okay, we're gonna say 1. Upload. Finish. We're gonna finish up the collision branch for the dungeon game. And then 3, use fast. Use our fast renderer in the dungeon game. And that should make a nice little 1-hour stream. I might actually do this off camera in between streams. I'm not totally sure. We'll find out. There's going to be no stream this weekend, unfortunately. I'm going to be visiting family back home in Adelaide, which is going to be awesome. Really looking forward to it. Haven't been for a little while because we've been in lockdown. So that's going to be great. I think this was a pretty productive stream. I think we did some cool stuff. We're a little bit off of our mark. We're going to have to do some investigation about why our triangle rendering is so inefficient. Like I said, most likely still Lua limitations. I guess one thing we can think about, and let's make this as just a little side note here, benchmark. We want to try and benchmark our 2D in pure C, right? Remove Lua as a variable in the equation. Just see what pure C performance looks like. Just call these APIs in C. If we get drastically better performance, that's going to be very telling. I'm not super concerned, right? I'm not thinking about pushing the PlayStation 2 to within an inch of its life. I'm happy to burn efficiency using Lua because it'll be a much nicer programming environment. So, but it would be good to at least know what the cost of using Lua is and understand how we can build effective abstractions in Lua that minimize that cost, if it is even this. It could just be the way we're doing DMA. All right, awesome. I'm just going to keep talking if I don't hit the off button. So that has been another really wonderful stream. Thank you very much for the delightful messages in chat. Thanks you for tuning in. Thanks for everyone watching this on YouTube. I'm Tom, and I will catch you hopefully very shortly. See you next time.